Welcome to C++ from Python. This is meant to be a gentle introduction to C++ for Python programmers. Prerequisites. So I assume the following. First, that you have some introductory experience with Python. You don't have to be an expert. You don't have to be a professional. If you've taken one course, not even a long course, that's probably enough. If you know some basic flow control, the idea of functions, and a little bit about types and things like for loops, if those terms are all familiar to you, you're probably going to be fine. Second, I assume that you have a working email account. We'll need that for interacting with some of the online tools we'll use for this course. And finally, you need a recent browser. So typical examples, Chrome, Firefox, Edge, Safari. It's very unlikely that you're not already using one of those, but the tooling we will use, again, will be online, so you need an up-to-date browser. For this class, I intend for the lectures to be around 30 minutes each or less. At the end of each one, there will be a homework assignment. For these homework assignments, we're going to keep all of our work in a single GitHub repository. You will maintain one GitHub repository for all of your work, and in that repository, you will keep one folder per assignment. And within that folder, you can save the code for the assignment and any written answers that might go along with that. And our goal is to be able to do some basic programming exercises using C++ as our language. As an example, Project Euler.net is, in my opinion, a really good repository of programming/math problems. They tend to require a little bit of work in both of those axes, but the first few problems should be very straightforward if you have a basic working understanding of any programming language. So that's where we'd like to reach over the next few lectures in C++. Now, what is C++? It's a compiled language, which is probably a new thing to you if you're coming from Python, possibly not if you're coming from some other languages. This means that running code requires two steps. After you've typed your code, that's not the program like in Python. That code is a recipe for a program. You have to run it through something called a compiler, which turns it into a program, and then you can run the program. This language is based on C, a systems programming language with about 50 years of history at this point. C++ is multi-paradigm. That's a fancy way of saying there's more than one way to do things. There are multiple styles of programming, and C++ tries to make many of those styles accessible to C++ programmers. That doesn't mean that C++ is the best language for some of those styles, but it tries to offer quite a bit of power in how you use it, with one big caveat in that it favors efficiency over everything else. The famous rule in C++ is that the language only makes you pay for the features you use. So if there is something the language could do for you to make your life easier, but it would make the program slower, then by default, it does not do it. There are some negatives when compared to Python. First of all, C++ is more verbose. Simply put, it takes a bit more typing to express the same ideas in C++ that you might in Python. Also, the standard library is very anemic in comparison. Whereas the standard library for Python includes things like a web server, compression file formats, database formats and APIs, tons of stuff that you might want to do is already there and ready to be used. In C++, the standard library only contains very basic building blocks. And if you want to do something more advanced, you have to go out, you have to find somebody else's library that you'd like to use. And actually, all of these things combine to make it a bit harder to experiment. If I want to try a quick idea, it takes a little more, not a ton more, but it does take a little more time than it would in Python. I have to do a little more typing. If I want to do a test web server, I have to download and install a library as part of my experiment. And then when I'm ready to go, I have to compile my program and then run it. There are, however, some real advantages. And the first, the efficiency. A C++ program can be written to be very fast. C++ enables you to write code that is pretty much as fast as the machine is physically capable of running it. That doesn't mean your code will be fast. It allows you to write fast code. And what this often means in comparison to Python might be a difference between 10 and 100 times improvement in how quickly your program progresses, or similarly, a 1 over 10 or 1 over 100 factor in the runtime of your program. The other advantage is static checking. So static checking refers to the compiler's ability to look at your program, look at your code when it's creating your program and make judgments about, is this safe? Is this correct? Is this an acceptable program? And in Python, many of the things that we could check if we were in C++ can't actually be determined until you run your program. And what you'll eventually learn is that when it comes to errors, we want to discover them as soon as possible. And compiling our program, well, in some ways it slows us down. It also exposes many errors much sooner. Compilers. So when it comes to running Python, most people have probably used something called CPython, which is the canonical Python implementation. There are others, but there is one that's considered to be the main version of Python. On the other hand, with C++, there is no one standard C++ compiler. I've listed 3. There are others. These are, to me, the 3 that seem to be most widely used. Microsoft Visual C++, it's Windows only. It is a very good compiler. The GNU compiler collection is maybe I'm pretty certain it's the oldest on this list. It's more or less the de facto standard open source C++ compiler. But then it also has a much younger competitor, Clang, which came about, I think, a little over 10 years ago and has really grown in adoption. Now we're going to use Clang because not only is it available everywhere and free, but it has a reputation for having the best error messages. I'm not saying its error messages are perfect, but if you write your program and you make a mistake and the compiler looks at it and says, I can't make a program out of this, there's a bug, you're far more likely to be able to understand the error message Clang gave you, in my opinion, than some other C++ compiler. Finally, we're going to be using the C++ 11 version of the language. C++ has been revised several times over its lifetime. There have even been several major revisions since C++ 11, but this is the version that gives us a really solid baseline. We're not going to be doing anything so advanced that we need features newer than this, but C++ marked a really good point in the history of the language where a lot of important tasks actually got simpler. And one other note about C++11 is if you also do the US Computing Olympiad, if I remember correctly, as of the last time I checked, C++11 is the newest version of the language that their platform supports. And by the time you're watching this, that could have changed. So for this class, we need tools. We're going to use GitHub to save and submit your work, as we said earlier. By default, and the most convenient way to use this is for all of your code to just be publicly visible. If you're a little bit hesitant about this, I'd recommend you get over it. I'm not trying to be mean, but every programmer starts off at some point not wanting others to see their code. As we get better, we become less ashamed. We all make mistakes. We are all beginners at everything we know at some point. However, if you do really have strong reasons why you can't share your code publicly, still use GitHub. You can set it up to be private, and then whoever you're working with for this class, you will just have to agree on some other way. Either you will share the repository only with them, or you will agree on some other way to have your work looked at. And we're going to use a website called Replit for actually developing, compiling, and running your code. This is a totally online IDE. It includes Clang. It runs in your browser, so there's nothing to install locally. This isn't the most important reason even to do it. It's certainly convenient, but the most important reason is then it's very easy for all of us to use exactly the same tools. If some people are running Windows and some people are running on a Mac and some people like me would prefer to run Linux, it doesn't matter. It is the same compiler, the same interface, no matter where you come from. You just have to be running in a modern web browser. Now, if you still don't like that and you want to use your own tools, you can, but you're a little on your own. You are going to have to install it yourself. It's less likely that somebody else is going to be able to provide you help and support, as in somebody else who is either taking or has taken or is helping with this class. And if you are using a different compiler, you might have different error messages. It might look different than examples we go over in the class, and different features might be available or not available. For C++11, it should be pretty uniform in this point, though. Now, hello world. In every programming language, we start with hello world. If you go to Replit and you just create a new C++ REPL, it'll give you this in a file called main.cpp. We'll discuss the pieces of this program a little more during the next lesson. But for now, let's just look at it on Replit. I want to see what it looks like on Replit. This is me. This is, oh, it's a C++ Replit. Here's the file I have open. We see the syntax highlighting is automatic. This on the right is the terminal where you can interact with it. You can just use the run button up here, but we're going to want to learn at least a little bit about how to use the terminal. If you've never used a terminal or a command line interface before, it'll take a little getting used to. It's simple, but I believe for C++ it's worth learning because you are going to have to ask a little more precisely for each of the steps you want done. And over here, by the way, there's files. You can have multiple files, multiple folders. By default, there's only the one file here. Now, on to the homework. Very little of this is actually C++. This is mostly your initial setup. First, I'd like you to create a GitHub account. And this is free. Again, you just need a working email address, and you can have a free GitHub account. By default, repositories are public, but sometime within the last year or so, they actually switched to you can also have private repositories without paying anything, if that's what you desire. Second, I want you to create a free account on Replit. Okay, kind of the same deal. You have an email address, you have a browser, you can sign up for a free account. Now I want you to go to Replit and create a new C++ REPL, and you should see it automatically include Hello World. Now step 4 is important. We're going to connect Replit to your GitHub account. This will allow Replit to save your changes when you ask it to. You still have to say, please commit this to my repository. It's kind of like writing it down on paper is one thing, Replit will remember it, but handing it in is another. I'm just going to show you. I've already set this one up, but here you would go to this version control tab on the left, and this is going to give you options here that allow you to connect it with your GitHub account. I want you to do a little bit of experimentation. First, what happens when you click run? And I'd love it if you guess at the answer to this first. So, some of these are written questions, by the way. I'd like you to just put them in a text file in the repository. I want you to create a new folder, homework, with this lecture number, and copy the main.cpp file into it. And then I'm listing exactly the commands you need to compile and run your program. I am asking you to try out doing this at the terminal, at the command line interface, because it's making the fact that there really are 2 steps here a little more explicit to you. Clang++, this is the command that invokes the C++ compiler. This is an option that tells it we're specifically targeting C++ 11. Replit by default will actually pick C++ 17. If you want to use a newer version than 11, you're welcome to. Next comes the name of the C++ file. And since I'm asking you to put in a folder, you're going to give it the file name within a folder, where on this system, you separate the folder from the file name with a slash. Finally, -O for output, that tells it the name of the program to create from that source file, and we'll call it main-0.0. Finally, if you want to run a program that is in your current directory, just to be precise about what this means, the dot means I'm starting in my current directory, and within that, I want to run main-0.0. Next question, what happens if you remove the \n? If you've done some Python, you've probably already learned what \n means and can probably reasonably guess what's about to happen. Next question, what do you think each part of int, main, open paren, close paren means? So the int here, and then these parentheses. I'm intentionally asking a slightly obtuse question because based on your intuition from another language, you might guess partially what those mean, but then look for something to match it up to and be a little lost. I'm asking you to take a wild guess and write it down. Finally, I want you to change the output message. You know, just change it a little bit, something different than what it started, so that you have changed the code in some trivial way. And then I want you to commit it and push and send either me or whoever you're working with for this class, send the GitHub link. And just to remind you on how we're submitting, homework is submitted by emailing a GitHub repository link with the following. So the repository has to have a folder identifying this lecture, that is the homework for this lecture. And written answers, ideally just put them in a file called answers.txt. If you name the file something else, whoever's working with you will still probably find it. But the more uniform you make it, the more precisely you follow these instructions, the easier you make it on whoever you're working with. So Best of luck, and I hope you join us again next time. Thanks.